Hello, welcome to my video on data structures. This is part 5 for linked list. In this video, we will test our implementation. First, let's look at the inputs. We have two sets of integers shown here in the slide. We will primarily operate on the first set of integers, and we'll use the second set to test our splice or merge operation. Let's begin with testing whether we can properly read in the inputs. In line 2 of the code, we instantiate a linked list object. We can test the constructor function here. In lines 6 through 9, we read in the input integers and insert them into the linked list using the pushback operation one by one. In lines 11 through 15, we print out the content stored in the linked list. In line 11, we can actually test three functions. We can test whether the begin and the end operations can properly return the correct iterators. We can also test whether the increment operator, or ++ can properly traverse the entire linked list. Meanwhile, in line 13, we can further test whether the dereference operator, or star, can properly access the data content. The output of the code segment is shown at the bottom of the slide. We can compare the input and the output to confirm these functions work as intended. Next, we will test the search operation. In line 2, we will first search for a given integer 18 from the linked list. Then, in line 3, we check whether the iterator returned by the search function corresponds to the end iterator. If yes, it means the function has searched through the entire linked list and cannot find the search key. In this case, we output a message data not found in line 5. Otherwise, we delete the search key from the linked list in line 8. Since the search key 18 is not contained in the input, we will expect the search to fail, and we can indeed see the message data not found from the output. In addition to testing the search function for its failed case, here we also try to test its success case and see whether the search key can be deleted from the linked list. We have exactly the same code segment as before, except that we are searching for integer 57 that is present in the linked list. By looking at the output, we can see the search function indeed finds the search key and properly returns its corresponding iterator. Meanwhile, our erase function also successfully deletes 57 from the linked list using its iterator. Next, we will test the more generic version of the erase operation that works on a range. We obtain the start and end iterators for the range in line 1 and 2 and call the erase operation in line 9. Recall that we expect the erase operation to delete all data elements in the range except the last one. As shown in the output, we can confirm the integers 10 and 23 are deleted, and the last data element 14 remains in the linked list. We then test the insert operation. In line 1, we try to insert 33 at the beginning of the linked list. And in line 2, we try to insert 66 at the end of the linked list. From the output, we can see that both numbers are correctly inserted. Next, let's try to test the splice function. In line 1 of the code, we obtain the iterator for the integer 123. In line 2, we try to splice in the entire set of integers from the second input set before 123. Recall that the second input set just contains numbers from 1 through 10. From the output, we can see that those numbers have been properly inserted before 123. The second linked list becomes empty after the splicing, and this is shown as an empty line when we try to print out its data content. Then, we test the push front and pushback operations. In line 2 and 3, we try to insert 98 at the beginning and 75 at the end of the linked list, respectively. From the output, we can see both numbers have been inserted to the correct locations. Finally, we test the pop front and pop back operations. In line 2 and 3, we try to delete the first and the last data element from the linked list, respectively. And from the output, we can confirm both numbers are properly removed from the linked list. In summary, we have tested our implementation of the linked list data structure. In the next video, we will start the discussion of two new data structures, the queue and the stack. Thanks for watching, and see you in the next video.